Question 7 is coming from circular measure. In the diagram, AOD and BC are two parallel straight lines. Arc AB is part of a circle with center O and radius 15 centimeters. Angle BOA is theta radians. Arc CD is part of the circle with center O and radius 10. Okay. Angle COD is pi over 2 radians. Show that theta is equal to 0.7297, correct to 4 decimal places. All right. Now, when you look at this one here, I can create this vertical line here. Okay. This vertical line here, because it is not part of this one, I can make it dotted. It's not part of the shape. I can make it dotted. Now, this one here is 10. If this is an arc whose center is O and it is 10, this length here is 10, the radius, even this one has to be 10. Okay? So I'll put a 10 here, 10 centimeters. That means even this one is 10 centimeters. Not so. But of course, this one is 15. We don't know this length here. So if that is 15, and this is an arc whose center is here, if this is 15, even this one is 15. So that means I'll put 15 centimeters here. So using this triangle here, we can actually have, for any right angle triangle, because this one is a right angle triangle, then we can use SOHCAHTOA. Okay, so using SOHCAHTOA, then this one is the opposite side to this theta, and this is the hypotenuse. So opposite and hypotenuse, that will be a sine. So we shall say sine of theta is equal to the opposite, which is 10, out of the hypotenuse, which is what? 15. So meaning theta is going to be equal to the arc sine of 10 out of 15. Here your calculator must be in radians. Calculator in radians. So in circular measure, please remember this one here, that the calculator has to always be in radians. So I'll get my calculator and then we get the answer. My calculator here is in degrees, so I have to change it to radians. Shift, then mod, rad is 4, and then I can put shift, then sine, then 10 out of 15. What does this one give us? That is 0.7297. You see, to 4 decimal places, 0.7297 to 4 decimal places. That is that. Then part B, find the perimeter and the area. Okay, find the perimeter and the area of the shape ABCD. Give your answers correct to 3 significant figures. Perimeter is the sum of all lengths around the shape, right? Now, when we come to this shape here, we need BC, okay? We need the arc length, and remember arc length is equal to r theta, okay? Then this one here, we need this arc length. This one, we know it is 10, this is 15. So we need this arc length, the length BC, the arc length here, and the 25, okay? We don't need these ones that are inside perimeter. We are looking at the lengths that are enclosing the shape, all right? Around the shape. So these ones are not around, they are actually inside. So we need to find BC. But when you look at this one here, this one is also a right angle triangle. So if I have this one, I can get this one using Pythagoras theorem. So that means BC squared plus this one, OC squared, is equal to 15 squared. Okay, so therefore BC, so I can say using Pythagoras theorem, then BC is going to be equal to the square root of that 15 squared, then minus 10 squared. Okay, so 15 squared, that is 225. 225 minus 100, that is 125. So we shall have the square root of 125. So then what will be the perimeter? So perimeter is going to be equal to the arc. Which arcs do we see? We have AB and then CD. Okay, arc AB. Okay, then plus we have BC, which we have gotten here, then plus the arc CD, then plus these two lengths here. I can just say AD, which is 25, right? I can just say AD. Then arc AB, r theta. So what is the radius? The radius is this 15, okay? Then times the theta, which is here. So 15, then times this one we have gotten here, which is 0.7297, then plus BC, which is square root of 125, then plus arc CD. When we go to CD, the radius is this one here, but the angle is 90, which is pi over 2. So we shall have 10 times pi over 2. And then plus AD. AD is here, is 15 plus 10, which is 25. So I'll have 25 here. That means all together here, what do we get from our calculator to three significant figures? 15 into 0.7297, then plus the square root of 125, then plus, of course, that will be 5 pi, then plus 25. This one will give us 62.8 centimeters to three significant figures. That is our perimeter. Then let's go to the area of ABCD. Okay, so we just get these areas and then we add them. So there is area of this sector, there is area of this triangle, and there is area of this quadrant here. So we shall say area of sector. That will be area of sector OAB, then plus area of triangle, the triangle is what? OBC, then plus area of sector OCD. Area of a sector is a half r squared theta, right? So what is the radius for this one? It is a half. Then the radius for OAB, that is 15. So we have 15 squared, and then the angle is 0.7297. Then the area of the triangle is a half base height, okay? So this BC here, and then this one here, right? So we shall have a half times 10. That is a half times 10, then times the BC, which we got as square root of 125. Then plus area of the sector, OCD. Of course, that one is a quadrant, is a half. A quarter. This one we can just say a quarter area of a circle. But if I take a half r squared theta, okay, a half, then r, what is the radius? The radius is 10. A half 10 squared, then the theta is pi over 2. So if I had taken a quarter times area of the circle, which is pi, then r squared. Do you see that it is the same thing? Pi over 2 times a half, it is a quarter, this one. You see that? That is that one there. So we are now going to put everything here in the calculator and we write our answer to three significant figures. We have a half of 15 squared, then times that 0.7297. Then we also have a half times the 10 times the square root of 125. Okay, then we shall have a half, then times 10 squared, that's 100, then times pi over 2. So to three significant figures, this one will give me 217. 217 centimeters squared to three significant figures. That is that.